Today's lesson is on the molarity of ions. So back in the lab, we have these little dropper bottles and they all have labels on them that include the molarity, like 0.10 molar. And that's the molarity of a lot of our dropper bottles. And it also tells you a chemical, calcium chloride. But if we remember our studies of ionic compounds, which calcium chloride is, when we dissolve it in water, we don't really have any calcium chloride left. So even though we write this on our bottles, it's technically not true because the calcium chloride doesn't exist as a unit anymore. When we added the water to make the calcium chloride solution, it's separated into calcium ions and chloride ions. And if you remember, we had two chloride ions here and we put the two in front. And we can put aqueous here and aqueous here. So when I have a 0.10 molar solution of calcium chloride, I actually don't have calcium chloride. I really have calcium floating around in solution and chloride ions floating around in solution. So sometimes we need to think about the calcium and the chloride separately. So here's a question you might be asked. What is the concentration of chloride ions in that 0.10 molar calcium chloride solution? So as we had on the previous page, we have calcium chloride dissociates. Remember, this is called a dissociation equation into calcium ions and chloride ions. And I hope you still remember all your ions. This one's easy because you can figure out the charges from the periodic table because calcium's in the second column and chloride is in the halogen column, one next to the noble gases. So you can figure out their 2 plus and minus. So let's try to answer this question. What is the concentration of chloride ions in a 0.10 molar calcium chloride solution? Well, for every one, remember that's implied there, every one calcium chloride that we dissolved in solution, we got one calcium and two chlorides. So you could probably do this problem in your head. What's the chloride concentration if I start off with 0.10 molar calcium chloride? Well, the chloride concentration is just twice that amount because for every one calcium chloride, I get two chloride ions. So I would have 0.20 molar chloride ions floating around in solution. How much calcium ions do I have floating around in solution? Well, for every one calcium chloride, I get one calcium ion, so I still have a 0.10 molar calcium ions in solution. You can also do this problem using a unit analysis. So if I wanted to find the concentration of chloride ions, if I wanted to find the moles per liter of chloride ions, I could put that as the end. And here I'm not going to separate it into moles and liters because this is a kind of a quick problem. So I can actually solve this for moles and liters at the same time, and I'll show you how to do that. So this is my starting point. I have 0.10 moles of calcium chloride over 1 liter, but I want the moles of chloride per liter. I do not want the moles of calcium chloride. So how do I change moles of calcium chloride into moles of chloride? I use this balanced equation because I have 2 moles of chloride ions for every 1 mole of calcium chloride. And notice I get the answer, which we already knew was 0.20 moles per liter of chloride ions. So anytime you have an ionic solution that's dissolved in raw water, technically you only have the ions that are in solution. So we have calcium ions in solution and chloride ions in solution. And you can calculate the molarity of the cation, which is the calcium, or the anion, which is the chloride. You may also be asked to solve other types of problems, but once again, we're just going to use the same techniques we have in the past to analyze these problems and calculate them using unit analysis. So let's try this one. A 250 milliliter solution of aluminum nitrate has a nitrate watch out, it's not an aluminum nitrate, just a nitrate concentration of 0.82 molar. And a lot of times we are concerned with one of the ions in solution. We're going to be doing a lab about the chloride concentration in our river water, and there we care about just the chloride part that's dissolved in the river water, because that can be harmful to aquatic life. So here we have a question. A 250 milliliter solution of aluminum nitrate has a nitrate concentration of 0.82 molar. How many grams were used to make the solution? So we solved this the same as we've done other problems involving molarity. So notice I have this 0.82 capital M. I can't leave it as 0.82 capital M. I'm going to have to put that as moles over liters. All right. So I'm going to remember that 0.82 moles of nitrate over 1 liter. And if I need to, I'm going to reverse that. Okay, so I'm going to use this somewhere in this problem. And I'm also going to have to remember that aluminum nitrate doesn't really exist as a unit together because it dissociates or separates into the aluminum ion and 3 nitrate ions. So I'm going to use this information to solve the problem. So how many grams? So I'm looking for grams, so I'm going to say grams. And this time I'm looking for grams of aluminum nitrate because I can't go buy a bottle of nitrate. It's with something. So I'm grams of aluminum nitrate. What am I given? Where am I going to start? Well, I'm given 2 things. I'm given the milliliters and I'm given the molarity. And in a previous video, we said it's often helpful to start with something besides the molarity. So I'm going to start with the 250.0 milliliters of solution, and that's over the number 1. So now I'm going to have to go from milliliters to grams, and I need to get to aluminum nitrate. So how do I do that? Well, I've got to cross out everything until I get to grams. So I'm not given any other information in my problem about milliliters, but you should remember your conversion factors, and I know there are 1,000 milliliters in 1 liter. All right, so now I'm at liters. I need to get to grams, so I'm not there yet. I have something with liters from the problem. I have the molarity, so I can use that next. So I have 0.82 moles of the nitrate for every 1 liter. So the liters cancel. But I want grams of aluminum nitrate, so I have to keep going. I'm only at moles of nitrate. Well, what do I do next? Well, I want to get to aluminum nitrate, and I'm at nitrate. So I'm going to use my balanced equation. I have 3 moles of nitrate for every 1 mole of nitrate. So moles of nitrate cancel. For every 1 mole of aluminum nitrate. So let me clear that off and write aluminum nitrate. Aluminum nitrate. And I get this from this balanced equation because every 1 aluminum nitrate breaks into 1 aluminum and 3 nitrates. So now I'm at moles of aluminum nitrate, and now I need to get to grams. So I'm going to use the periodic table. I'm going to look up 1 aluminum, 3 nitrogens, and 9 oxygens, and add that all up together. And I get a grand total of 212.996 grams of aluminum nitrate for every 1 mole of aluminum nitrate. And as you can see, I'm running out of room. So I'm going to write that on top, aluminum nitrate. And write that on bottom, aluminum nitrate. So here we have it. Milliliters cancel, liters cancel, moles of nitrate cancel, moles of aluminum nitrate cancel. I'm at grams of aluminum nitrate. So this type of problem is just like our previous problems. You keep canceling until you get to what you want. What resources do you have to use? You have conversion factors you can use. You have the periodic table you can use. And you can use the information given in the problem itself. We put it all together until we get to the wanted units, which is grams of aluminum nitrate. And we get a number on our calculator, if we do the math, of 14.555 grams. But I only have 2 sig figs from this number, so we're going to round that to 15 grams, and that's my answer. So there we have it, problems involving ions using a dissociation equation. So hopefully you can pause the video and write this down and use this as a reference so you can have something to look back to when you solve problems on your own. Thanks for listening. Try some yourself.